so people can see us now. All right, it is kind of 7 o'clock. What do you think, Anna? Should I let the people in and then
I think
we
so.
wait another minute or something?
Wait another couple of minutes, yep, and then
Okay.
I'll start sharing. Yep.
Okay, so let's see. Mute participants. Upon entry. Okay. Okay, I'm gonna admit them all. Hey, and there I see Guy. Perfect timing, Guy.
Yep.
Okay, let me see where Guy. Okay, I'm gonna make Guy co-host. Hi, Guy. You should be able to turn on off your mic and your camera.
Yes, I just noticed that. Hi, everybody.
Perfect.
Hi, Albert. Yeah, thanks for this.
Oh, totally.
Sorry, my Gmail was a bit slow today. I just got your message now saying that dial in 5 minutes before.
It's okay. It worked out, so.
Great. You should also see me.
Yes.
Yep.
Perfect.
Great.
Okay, so should we start? Okay.
Sounds good, Anna.
All right. So how does that look? Okay, good morning, everyone. Welcome to the Global Flood Partnership 2020 virtual sessions. This is the 4th session on flood resilience. Thank you all for joining. I will be hosting together with Mark Trigg, whom you met last week, if you were tuned in, and Albert Kettner, who's been hosting all of our sessions. And just a couple of things about myself. So I work at the University of Maryland, Baltimore County, in the Washington, D.C. area in the U.S. And I also work at NASA Goddard Space Flight Center on building capacity for remote sensing, including flood applications. So just a brief introduction to today's, somehow it's not, okay. Yeah, okay. So a reminder that these webinars are recorded, will be recorded and posted on the website shown here, which is the Global Flood Partnership website. And a little bit about the Global Flood Partnership, and some of you may have heard this before from the previous sessions, but we work on building partnerships for global flood forecasting, monitoring, and impact assessment. in order to strengthen preparedness and response to reducing global disaster losses. So it's a cooperative framework between scientific organizations and the managers or other users of the type of data that you can use for flood applications. So, let's see if I can get rid of it. Okay. So the purpose of the partnership is to bridge the gap between the science and the users, and to establish this partnership that I already mentioned, and in order to strengthen preparedness. And sorry, I'm having a little trouble with my slides. Okay, so the other goal is to share and to promote, share results from the latest scientific developments in global flood risk management tools, to promote research in special sessions and also in conferences, as well as our annual meeting, and then supporting projects that are related to global flood risk research. And finally, also to publish all this work in papers and other documents that result from these collaborations. The GFP also has a support service, which is a means of connecting the scientists and developers of these global flood risk management tools with the practitioners. So it can be activated by any GFP member, and it's a mailing list. You can activate the service by sending an email to the list with a request regarding assistance for any ongoing flood or event. And you can connect to this list in the URL shown here. So I have 3 ways to connect to the Global Flood Partnership here. One is the website that I just mentioned. Here's a screenshot, and that's where you can access the events that we have coming up. There's the group email, which is also the way to activate the service. And then also through the webpage, you can access information on events. So that's a brief summary. You can contact us if you want to learn more. So it's free to join. So if you're interested in staying connected, you can click on the group email link to receive, to be connected. So if you were on the other sessions, this session will be organized similarly. So we'll have 4 presenters, which I'll be pleased to introduce in a minute. There'll be opportunities for you to get involved by asking questions through the chat box at any time during the session. After the 4 presentations, we'll have a panel discussion where you can also ask questions. And when you do that, when you do use the chat window to ask questions, remember to indicate which presenter you want to ask the question to. So during the discussion, you could also click on the raise hand symbol, which you should be able to see on your screen. And we can also unmute you and invite you to ask a question. So one last item before introducing the speakers is that we would like to have some feedback on what you thought about the entire online experience with the GFP this year. So if you don't mind filling the survey, that'll help us figure out, what worked and what didn't, and also it will give us some feedback on planning for future year conferences. Do we want to do the same thing? Because usually our conference is in person. Obviously, this year we couldn't do that, but we'd like to see how what people thought about this format for the future. So the survey is short. It will only take you, 3-4 minutes to fill it out at most. So with that, I'm going to introduce our first speaker, who's going to talk about a simple participatory tool to assess community flood resilience. His name is Colin McKiston, and he is with Practical Action, where he's the head of climate and resilience. And he has worked extensively on issues related to poverty dimensions of sustainable development, disaster risk reduction, climate change adaptation, and loss and damage. So his main areas of interest are in system approaches, complexity, resilience, and responding to the challenge of climate change. He's also the co-chair of the Bond Resilience Learning Group, which is a collaborative NGO platform that promotes learning and understanding of resilience. And he's also on the steering committee of the Bond Development and Environment Group. And I will tell you more about the other speakers in turn after Colin's presentation. And that is my introduction.
Thank you very much, Anna. I can just put my presentation up. I'll be ready to go. Right. Share screen. Can I just check you can all see my presentation? Thumbs up?
Yes.
Great. Okay. So good morning, good afternoon, good evening, everybody. It's a great pleasure to be here. And I think I should clarify one thing. This isn't a simple tool, but I will be sharing with you over the next 15 minutes the work that we've been doing as part of the Zurich Flood Resilience Alliance. And the aim of that work is to develop a tool to help us understand what are the practical activities that communities, particularly on the front line of flood impact, what they can do to better prepare for future flood events. The Alliance is an alliance of 9 organisations. There are 5 practitioner organisations, of which Practical Action is one. Practical Action, Concern, Mercy Corps, the International Federation of the Red Cross, and Plan International. Then we've got 3 research partners, the International Institute of Applied Systems and Analysis, IASA, which is based in Austria, ICET International, which is based in Boulder in the US, and the London School of Economics. And then supporting this whole alliance is the Zurich Insurance Company. The Z Zurich Foundation finances the program, and Zurich Insurance Company itself actually provides risk engineering inputs into the program. And we're working around the world in both developed and developing countries. And we're working at the community level, and we're particularly looking at communities that are flood vulnerable. And the majority of those communities are flood vulnerable to riverine flooding, but we've also got communities that are susceptible to surface flooding and also coastal flooding events. And as you can see, we've got a good distribution between developed and developing countries across that hazard profile. So the challenge for Practical Action, we're a UK-based civil society organisation. We've been working on development issues since the mid-1960s, and we have a global programme on climate and resilience, very much built around hydrometeorological hazards, which we're seeing increase as climate change takes hold, and in particular a focus on flooding. We've worked in the past a lot around technology, so the role particularly of early warning systems and forecasting in developing appropriate responses to floods has been a large part of our programs. So these are just some photographs from our programs around the world. And as you can see, the communities that we're working in next to rivers, on coasts, they are facing increasing floods. And the graph there is really just to indicate that this is getting more severe, more intense, and happening more frequently. And many of the communities that we're working with are demonstrating the point at which they are struggling to progress because of the repetition and the impacts of those flood events. So we've been thinking what it is we need to do to better help those communities be prepared and respond to this changing conditions, and hence our participation in the Zurich Flood Resilience Alliance. Now, one of the first things that we face when we go into communities is, I think it's twofold. First of all, communities on the front lines of climate change have numerous challenges that they're trying to struggle with. They've got issues around education, around health, around infrastructure. But we're going into those communities very much with our expertise around resilience building and around the roles that risk reduction can play in improving the livelihoods and well-being of those communities. So we started out with the Alliance and with our work around the world to think about what it is that we can do to help those communities better identify what they can do to build their resilience. Are there activities, are there aspects of their livelihoods or well-being which either place them, increase their exposure to floods, increase their vulnerability to floods, or are there things that they could do which would reduce that exposure or vulnerability? And I think overall we recognise that in many of the communities where we're working, and as part of the Zurich Flood Resilience Alliance, we're currently working in Peru, in Bangladesh and in Nepal, and we're hoping to expand our work to Africa to work in Senegal and Zimbabwe, and we're going to extend our program from Peru into our country office in Bolivia to bring in new flood scenarios. But we were very interested in trying to understand across that diversity of different types of community experience and the varying flood hazards that I've mentioned, what does resilience look like and how can we help communities with their existing resources plan better? So this alliance started out in 2013, and one of the first challenges we worked collaboratively on was to try and develop a resilience measurement framework. And this resilience measurement framework, we recognised, needs to be built on existing good practice in terms of community development. We didn't want to reinvent the wheel. We didn't want to recreate a new structure. We wanted to very much build this into existing good practice from a community programming perspective. We also, with our research partners, recognised that we wanted something that really helps to analyse the challenges that those communities are facing, and something that would then support impact assessment, and also, are we delivering the outcomes that we really wanted to deliver? And then finally, and one of the most important aspects of this work is it's not just about improving the situation for community X on that river, but it's generating that wealth of empirical evidence that we can then use to shift local government, national government, and global policies around resilience, flood resilience, climate resilience. So after a number of brainstorm meetings where the partners came together, we shared our expertise of what we were currently working on in regards to resilience building. We came up with a framework that is built on the Sustainable Livelihoods Framework, which has been around since the mid-1990s, building on the 5 capitals: human capital, social capital, natural capital, and then physical capital and financial capital. And we recognize that those capitals are sort of the underpinning foundations of communities' well-being and communities' livelihoods. But we also realized, and a lot of the global debate around resilience was focusing on things like absorptive capacity and adaptive capacity and transformative capacity. So we're not looking at those 5 capitals as whether they're present or not present, but whether those capitals are the sources of resilience or the weaknesses in regards to the resilience of that community. So what we're using is the 4R framework, which is an established framework for infrastructure resilience that looks at robustness, the ability to withstand the shock, redundancy, whether you've got functional diversity within your community, resourcefulness, the ability to mobilize when threatened or when needed, and then rapidity, how fast can things be moved around, how fast can assets and resources come to play. And using risk engineering expertise from Zurich, we're using a risk assessment methodology. So we're building our 44 sources of resilience on the capitals, on how they perform during a flood event. And then we're doing that measurement at the beginning of the project period, and then repeating it to get a snapshot of where the resilience of that community is over time. But most importantly, we've also got a post-flood measure that doesn't measure the sources of resilience, but measures whether those sources actually delivered what we thought they would deliver when we did the primary assessment. Now, one of the challenges that we faced right from the beginning was with the 5 capitals, communities are probably quite happy talking about maybe human capacity or social capital. But when you get into financial capital and natural capital, you often don't have the expertise necessary at the community level to be able to unpack what it is about ecosystem services or what it is about financial services that are either strengths or weaknesses. And equally, if you go to an academic, you'll get maybe an overview of what the basin integrity is in that area, or what the financial assets that communities might be able to access are in that area. But very rarely do you bring the two together. So what we wanted to do was we wanted to develop a tool that works across both the practitioner, the research, the expert environments. So what we've done is we've developed an online tool. And there are 2 sides to that online tool. There's a data collection methodology, which is we use smartphones and tablets to actually go out into communities to collect the information on the sources of resilience for those communities based upon a standardized framework of 44 sources of resilience spread across the 5 capitals and the 4 R's. But then what we do after we've collected that data, and we collect it using a variety of different sources, including household interviews, including focus group discussions, including key informant interviews, but also recognizing that a lot of this data might already be available in secondary materials. And so we're extracting data where available. We're of course trying to collect data from multiple sources for each source so that we're not so that we can triangulate between the two and to see whether there is harmony or discord within the sources themselves. And we're then using that information to then rank the sources based upon a risk engineering framework from A to D, where A is best practice, D is significantly below practice, and using the communities, the local experts to help us with both that measurement of the sources and development of the gradings. And then the data is output in the form of tables, a variety of different platforms. We've got a very interactive dashboard that allows people to interrogate that data from a variety of different perspectives. And this is just an example of the data collection exercises in the field. So using handheld data, it prompts you with the questions. There's a glossary contained within it in local languages that helps people to understand, maybe if somebody asks a question, what do you mean by an insurance product, or what do you mean by physical infrastructure? It has that information there readily available to hand so that the questioner can access that information, or they can share that with the person they're interviewing to help to really get some common understanding around what we're seeing as the sources of resilience. That data then, of course, is collected using informal interviews. We've got focus groups, we play games and use that as a way to capture more data, a variety of different methods, but then it's all brought together. Of course, the organizations have very different ways of working. The Red Cross, when they go into communities, they are very formal. They operate through their district structures. Practical action and concern, probably more on the ground, engaging with the communities directly. But we're testing this tool across those different types of operating environments. And then, of course, what's most important is not what we're capturing from the community, but taking it back to the community so that they can actually start to plan for it. So this is a community meeting in Nepal where data has been collected maybe 3 or 4 weeks earlier. It has been processed using the local project field staff, maybe some key informants from the communities and local national experts. And there you can see the data being presented. And I've just done a little screenshot of the types of ways that data can be presented. And here is just a simple bar chart with A being green, red being D, to give the community an insight into how they compare on a particular source across the different capitals. And it really is a way to help the community to try and understand what resilience looks like and where they can work, where they can't work, and what they need to do. Some of the outcomes of this process have been improvements in response measures, so training up disaster risk management or flood response units in communities so that communities have that access to the relief operations they need. Sometimes it's working with women's group to actually build maybe their capacity, their literacy, so that they can access financial services. It's about improving early warning systems. It's also about improving infrastructure. And the case on the right-hand side is a simple evacuation route from a school across a canal using a bamboo platform, so that when the flood siren goes, they know where to go when that message comes. We've also worked on developing infrastructure. So on the right-hand side, this is a flood shelter from one of our communities in Nepal. On the left-hand side, it's more about influencing national governments. And this is some work that we did with Tsunami, which is the Department of Hydrology and Meteorology in Peru, to actually influence their budget for 2020-2021 to increase the amount of funding that's going into early warning systems. Because we've recognized with communities throughout Peru that one of the issues is there's a lack of access to early warning information. We've also used the evidence from our work to develop policy pieces and research papers. This is at what cost, which is highlighting one of the things that we've learned. There is an inadequate amount of investment going into resilience building at the front line, and what funding is going through climate funding or DRR funding is failing to reach people on the front lines. The middle one, again, is increasing this access of early warning systems in Peru. And on the right-hand side is my colleague from Nepal speaking at a UN climate conference to highlight the work that we've been doing and some of the lessons from our community programs and why we need to focus on loss and damage and increase investment in adaptation. We've also developed a very simple post-event review assessment methodology, which can be used post-flood to look at what worked and what didn't work, and how can that be used to inform local governments, national governments, and global policy on better preparedness, better response measures when floods happen. We've also got an online portal where all of the tools and all of the information that I've shared today is available. And we also are developing local language portals in Latin America, in Spanish, in Nepal, in Nepalese, in Bangladesh, in Bengali, and also in West Africa in French, to disseminate this information to wider audiences. And finally, we're really interested in other people taking up this methodology. Everything has been developed, it's ready to go. And if you're interested, you can go onto our portal and download the Inviting Others document, which includes a form to then fill in to express your interest in piloting the tool, or maybe helping us understand from a research perspective what we're getting from the program. And I've also included in the presentation a set of links to other materials, and I'm hoping this will be available after the call for people to share. Thank you very much for the opportunity to speak, and I look forward to answering your questions at the end of today. Thank you very much.
Thank you, Colin. I actually have one quick question for you. So you talked about the 44 sources. So and you give grades to those. What's your criteria for the grades? I mean, you have some now. You know, what's your decision tree process for that?
Yeah, so all of the 44 sources have standard questions that we ask for collecting data on each of the individual sources. So whether that data is, maybe it's around access to schooling during a flood event. So that question will be standardized across the use of local languages as the tool in the different countries, but it will ask that question: does this community have access to education services when a flood event happens? Now that might be, do they still have access to the school? Or it might be, does the community actually organise some alternative form of education so that children have educational continuity during a flood event? Now, an A would be, yes, they do. And it doesn't necessarily mean that they gain access to the schools. It might mean that they have the informal education in the flood shelters, or the teachers come to the flood shelters to provide the education during the flood event. That is standardized across the board. We're using that standardization across all 44 sources as the way to capture the information to populate the snapshot of the resilience. But we're only really proving whether that snapshot of resilience is accurate after a flood event occurs in the community. And we do a post-flood measurement, which is part and parcel of the same tool, which asks, so when that flood event happened, was education maintained for those children? And again, an A would be, yes, it was. So the gradings are standardized, the questions are standardized across all five capitals, across the 44 sources of resilience. I hope that answered your question, Anne.
Yeah, thank you. Thank you. Yeah. All right. So thank you very much again. And our next speaker is Bais Ahmed. And so his background includes research in the field of disaster risk reduction, conflict and migration, and also climate change adaptation and community vulnerability assessment. He works at the intersection of conflict and disaster with a vision to help improve the living standards of forced migrants and stateless populations. He obtained his PhD in disaster risk reduction from the UCL, the University College London, and also has a master's degree in geospatial technologies from Spain, Germany, and Portugal, and a bachelor's in urban and regional planning from Bangladesh University of Engineering and Technology. And I think I mentioned at the beginning, he's with the Institute of Risk and Disaster Reduction at the University College London. So welcome, Bais. I hope I am pronouncing your name. I think I might not be, but anyway, I tried.
Yes, thank you, Anna. Can you hear me properly?
Yes.
And can you see my slide?
Mm-hmm.
Okay, so then let me start my talk. Yes, thank you, the Global Flood Partnership, for inviting me for the talk. So today I will give a presentation on a specific case study from Bangladesh, and I'm Dr. Bais Ahmed. I work at University College London as a lecturer, and thank you everyone for joining us today. Yes, before I start, I want to give statistics. You all know in the last 20 years, the number of disaster events has increased compared to the previous 20 years, like between 1980 and 2000, around 4,000 disasters were reported, but since 2000, we have around double number of disasters reported. So the number of disasters are increasing. Many link it with climate change. And among all the disasters in the both rows, you can see between comparison between 2 decades in between 1980, 1999, and 2019. The most prominent disaster was related to flooding. That's around 3,200. And the second prominent was storm, and that was 2,000 in the last 20 years. So more than 60% disasters, or even 65, are linked to flooding and storm disasters in the last 20 years. And we have earthquakes, number 3, 8%. That's most deadly disaster, but the impact of flooding and storm also brings flooding, like in coastal areas. The impact is really disproportionate in different income level countries. Like we can expect around 284 deaths per disaster in low income countries. That number is really low for high income countries, that is 67 only. So disasters bring, particularly flooding and storm related disasters, extensive impact and damage in low income and low middle income countries. So today I will talk about Bangladesh, a country from South Asia, very well known for flooding worldwide. You can see from the map, we are surrounded by India on 3 sides and sharing border with Myanmar on the southwest, southeast. And from the map, you can see mostly it's flatland country. Yellow is, the elevation is really low, close to 0. Just on an average, you can see on the southern coast, and also a vast majority of our country is low-lying land, just above 1 or 2 meters from the mean sea level. Also, we have the world's largest river network in this country, and we have more than 700 major rivers. Some of them are very well known, the Brahmaputra and Jamuna, Ganges and Padma, and other rivers. So crisscrossed by rivers, and as a consequence, because the low elevation, flooding is really very common in Bangladesh. This is yearly phenomena, and also some years we experience massive flooding. We experience hilly flash flooding, riverine flooding, and in the coast, of course, that is coastal flooding or tidal waves or tidal surge is very prominent. And also we experience river erosion. Some scientists are connecting the, you remember in the last 20 years, we are experiencing more flooding events. That's just double compared to the decades in 1980s. And the most recent flooding in July this year, it affected around 38 million people and displaced hundreds and thousands of people, and they lost their houses and livelihood. Some scientists have found this year's event, it is, we should expect this kind of event once in 20-year time, but we are now experiencing it every 3 or 4 years. And that is linked to anthropogenic climate change. So here's the flood map from July 2020. The red areas were flooded. Almost 1/4 of the country was flooded, mostly on the northeast central part of the country and also on the southern coast. Here are some photographs taken by our partners. This is how it looks. The communities are underwater. The last photo was taken this month. Still some areas are underwater. What are the impacts? First, pure drinking water. You really need to travel longer distances to collect pure water and store them on pots. And these are some typical images captured by our partners. This, you can see how it destroyed agricultural livelihood. Houses are damaged, and you can see children are swimming around their houses. So today I will talk about coastal flooding, mainly how it impacts the coastal community and its consequences, taking a case study from central southern coastal district, namely Patuakhali. We have been monitoring this community since 2015. So they are named as Noapara and Proserpina, highly vulnerable to cyclone and coastal flooding because the communities are just located above between 0 to 30 centimeters, not meter, above the mean sea level. Yes, there are early warning systems, but you remember the communities are protected by embankments or polders, and mostly these are tidal waves or flooding, and very difficult to predict and send early warnings. It's not, sometimes yes, the cyclone brings extensive flooding. The community has the map on the left. The yellow boundary is just sharing the border with the river named Golachipa, that is 5 kilometer width, And here are some photographs from the community taken by me during a fieldwork back in 2016. You can see the communities are protected by embankments on the top, some households just near the river, and you can also see the Golachipa River in C and D. Just after a typical storm or tidal wave, it is very common because these are earthen embankments and they get destroyed and the entire village is flooded. Also, it floods the agricultural land. Number C is the most safest house in the community. I took the photo, but just after a minor flooding, you see the house is almost underwater. And think about other houses or other community areas after a minor flooding. IFRC has defined community resilience as the community's ability to prepare for, cope with, and recover from this kind of flooding disasters without compromising their long-term prospect. Mainly, a community should have 6 characteristics. They should have access to different type of infrastructure and services. They should have both primary and secondary economic opportunities. They should be organized. They should know how to manage their natural resources like the rivers and the farmland. They should be knowledgeable and healthy and connected with all the components. So this is the framework we applied in the community. We wanted to understand whether the communities are resilient to flooding. So on 3 major things, we focused on livelihood, WASH, and DRR. And a number of activities were promoted by different partners and the government of Bangladesh and donors, like providing cash for work, cash for starting some secondary business related to grocery, poultry, rearing cattle, and yes, providing safety equipments and training. So we applied the typical household questionnaire and the focus group discussions type of survey method, and some highlights from the findings back in 2016. You see, they are trying to help themselves through different secondary sources of income, because the primary source for the men there is young men, is fish. I mean, they're fishermen and farmers mostly, but others like the women and elderly are involved in the first photograph, gardening, also grocery, showing machines, and rearing cattle. They also have now new raised tube wells in the top left, raised toilets in the top right, and new road networks for better communication. And also number D is the government provided cyclone shelter. So combining everything, we compared, I mean, before and after the project intervention, and we found all of the communities, like around 90% of them face disasters on a regular basis, like flooding and cyclone. But the number of school-going children has increased by 55%. Now they get early warnings, really good early warning systems. So their secondary source of income or earning sources has increased dramatically by 60%. And also they have now raised toilets or sanitary latrine around 88%. That was back in 2013, only 42%. Some improvements are there in terms of those 6 components of resilience, and we compared like how it is, you know, adding some benefits for the community in terms of all these different variables. In the first column, like whether their monthly income has increased, we found in 3 years' time it was increased. Also in many other, just to mention a few, whether they have any problem with drinking water, no. Whether sanitary latrines are available, yes. I mean, we compared how their performing on different resilience components, like whether they're knowledgeable on DRR, they have internal or improved road network. Yes, I mean, many things has or have improved, and we found they're more or less resilient to cyclone and flooding. But in this year, in May 2020, you all probably know about it, the cyclone Amphan, that the pathway was from India, that really impacted the coastal communities severely this year. 26 deaths were reported and millions of people were affected and houses were destroyed, as well as water points, bridges, roads, and livelihood. So what's the impact? Yes, we have done really well compared to 1970 cyclone that killed around 500,000 people in the coastal Bangladesh. The number of deaths was only 26 compared to that year in 1950. Also in other major cyclones, if you remember, the 1991 cyclone killed over 100,000 people, but our death rate has really reduced because compared to 1970, we have, that time we only had around 40 cyclone shelters, but now we have 12,000 cyclone shelters and we also have strong early warning systems that can evacuate people on time and save lives. So it took us around 50 years to make sure the communities are resilient. The death rate has significantly reduced from cyclone and all these types of flooding because of different type of structural and non-structural resilience interventions. But yes, still few things it cannot avoid. These are photos from this year in extensive, like near around 500,000 houses were destroyed. That's around 2 or 3 million people were impacted. Some photos from the field, you can see the embankment was destroyed. On the right hand, the river, on the left is the community. There is a photo, the tube oil, it is underwater, even erased it. And after massive cyclone and flooding, coastal flooding. And this is the communities right now. And this photograph was taken just 2 weeks ago, but the cyclone and the tidal waves, the flooding is still there after 6 months. That is really impacting the agricultural activities and livelihood interventions in the community. Remember, even after 6 months, they have this amount of flood water in many of the coastal areas. So it has really extensive impact. We found just only 8% of our country is less hazard prone. We have flooding, different types, and also drought in southwest and river erosion. We found a strong correlation between poverty and the intensity of natural hazards. These communities and districts are really, they're the most poor communities in Bangladesh. So there is because it destroys the livelihood, houses, the communities are inundated for between 2 to 6 months, and it takes time to repair again, but you face after 2-3 years again a massive disaster or flooding or cyclone like this. It impacts around 1 or 2% of our GDP. So it is really important to understand the local context, the culture and organizational setup. I really talk about last 15 or 20 years, one thing is really prominent in Bangladesh that was never before reported in massive scale, like disaster displacement is now very common. From these communities, around 15 to 20% people, they migrate. They are forced to migrate because the disasters, the floodwater for 6 months or more there destroys livelihood, and that causes poverty. Already these communities are fragile, and we try to provide lots of support through our resilience projects, but everything has some limits because you can see the vastness and extensive impact of those hazards. So we found overall in Bangladesh, around 7% people migrate because of this kind of environmental disasters, and 4% of them are found as climate migrants. The World Bank has projected there will be around 13 million displaced climate migrants in Bangladesh by 2015. As of today, we have something between 2 to 4 million. Many of them, those environmental migrants, convert into economic migrants, and disaster displacement is a new phenomenon despite having all those different projects, and that is really causing a massive problem for Bangladesh as well as for international communities. Yes, those people try to migrate, mostly young men, for a better living standard. This is highly debated. Are they mostly internally displaced, or some of them cross borders? And this is the findings from our recent work, not yet published, but you can see in Bangladesh, only 9% people migrate internally. Among them, 64% migrate solely related to economic, and among the economic migrants, 72% migrate because of environmental related disasters, and they're mostly coming from river flooding and coastal flooding types of areas. Displacement has been reported by the Internal Displacement Monitoring Center, IDMC. Last year in 2019, Bangladesh was among the top 5 disaster-related displaced country. In 2019, around 4 million people were displaced because of climatic disasters. 2020, it would be around 7 to 8 million people. And this is not only Bangladesh. Globally, last year, 33 million people were displaced. Among them, 8.5 million were related to conflict and violence, but extensively people were displaced, that is around 25 million because of disasters, and among them 24 million people globally were displaced because of weather or climate related events, and flooding was 10 million. The first was 12 million by cyclone, because cyclone also brings flooding, the coastal flooding. So disaster displacement is not a problem for Bangladesh right now, it's a global problem. And is it creating any humanitarian crisis? Because you all know thousands of people are illegally trying to cross the Mediterranean Sea and trying to enter Europe and other developed countries. There is a news from August last month how children and women and others are taking risks of their lives. But interestingly, this year, from the number of people who arrived in Europe between January and August, you see here the numbers, and Bangladesh is interestingly in number 6. I can understand from Afghanistan, 3,000, Syria, more or less 2,800. But why Bangladesh is there? We are not at war, or there is no massive conflict. It needs to be really investigated. And mostly they are young men who face poverty. Again, poverty is linked to disasters. And joblessness, yes, there's, because after so much flooding, how do you get jobs? And Libya and Tunisia are the main port of entry. And this year, this is out of many news, one just highlighting here, 24 Bangladeshis were killed by the smugglers in Libya who were trying to cross borders. So it is time to think about how flooding impacts community, their livelihood, and also their way of living. 10 to 20% people are being displaced from those areas, and it creates poverty at the end. That is the first thing to address by the Sustainable Development Goal. And is it linked to this kind of cross-border relationship? So it is really important to think about how the resilience intervention works from the individual, that's the bottom of this diagram, you'll see, to household, community, But we should not stop here at community scale, think about how it can be connected with national, regional, and global interventions for building resilience on flooding and climatic disasters. So a global network of helping each other and working in collaboration is really required. So that's all from me. Thank you. And you can email me anytime here. Yes. Thanks for giving me the scope to present.
Thank you very much for your talk and for joining us today. It's hard to wrap your head around some of the numbers that you mentioned, particularly the fraction of people affected even from just one event in this year, right? You mentioned the July 2020 event. So we have one question from Dang Nguyen who is asking, thanks for the talk. In your 2 coastal sites, any problem with sailing water intrusion? How about groundwater contamination? And then they say, I mentioned this because we find these 2 problems also in the Mekong Delta.
Yes, we have in coastal areas, we have so many other problems. One is groundwater pollution through saline water and also arsenic in some areas. Yes, I mean, I just talked about coastal flooding and some consequences of cyclone, but we have many other coastal hazards like coastal erosion, sea level rise, and scarcity of pure drinking water. And health, yes, disease and waterborne disease. So combining many other things, yes, it is really complex for the 30 million coastal people in Bangladesh. And probably that is not only Bangladesh, that's applicable for other coastal communities globally. You can see from this diagram. Thank you.
Okay, thanks. All right, so I have some more questions, but I think I'll wait till till later, till we have the panel discussion.
Yes, I'm
so
happy to take more questions. Thank you.
Okay, so I don't see any more questions. I'm sure there'll be more later. Oh yeah, okay, we have one from Juan. Could you talk a little about the flood warning system?
Yes, I mean, we have flood warning system in our country, but that is really very difficult. It's not functioning properly. We have a strong, I mean, really effective cyclone warning system because you can see cyclone is forming, coming 2-3 days beforehand. But for flooding, especially for coastal flooding with all those new dynamics of climate change, sea level rise, and storm, like the minor storms, things are really complex. And I told you, they have warning systems, but it really doesn't work and help the coastal communities to evacuate. And even they evacuate, what matters, because the water remains for 2 to 6 months. You know, I mean, what do you do? How do you come back? Your agricultural land is underwater, your gardening and all other, like where do you rear the cattle? So it's a complex problem, and you cannot all rely on fishing because there should be diversity on livelihood options. So it's a very complex problem, and yeah, we're trying in different innovative ways to resolve it. Let's see how it goes.
Mm-hmm. He also adds, is it built on a unified national level system?
Yes, we have flood forecasting system monitored by the Department of Disaster Management. Also, we have massive flooding in the north. I just talked about the south, and north was heavily impacted in the July 20, and this is from the May 2020 cyclone event. So yes, I mean, we have different types of flooding. Thanks.
Okay.
Yes, I have another question.
Yeah, from Antara Das Gupta. I was wondering about the height of the raised platforms and if they are decided based on empirical evidence or mean tidal levels?
Height of the raised platforms, probably for the toilets and for the water points, probably, if I can recall. Yes, they do some based on even the cyclone shelters, because we do some modeling first, what would be the height of the water, the wind speed, and this is how we located our 12,000 cyclone shelters. But to be honest, this is very expensive because there are different scenarios to raise the height of a water point or a latrine. It's possible because sometimes there are constraints of funding. So I believe there will be more funding upcoming from the Paris Climate Agreement if all countries sign it this year or next year on COP26. The promised 22 billion probably going to the low and lower middle income. And there we can really invest more on, yes, more modelings, more raised platforms, and also better embankments. That's to make the communities safer from flood inundation and flood water.
All right, thank you very much, Base.
Yes.
So we look forward to talking to you during the panel discussion again. So our next speaker is Guy Schumann. He is going to talk about the value of drones for bespoke local flood risk assessment in the Likungo Basin. He's with the United Nations World Food Program and has master's and PhD degrees in remote sensing and geography from the University of Dundee. He's worked at the University of Bristol as a research fellow and professor. And then he joined NASA's JPL and Caltech, where he worked on the upcoming NASA SWOT hydrology satellite mission. And then in 2015, he started research and development work on NASA-funded projects in the private sector by joining RSS. And he's now active in the R&D sector, both the US and Europe, and has affiliations both in the University of Bristol and University of Colorado Boulder, sorry about that. He's also a scientific advisor to the UN World Food Program. And his work focuses on large and fine-scale flood inundation modeling and integration with remote sense data that is geared towards interoperability of products to assist in flood disaster response. Welcome, Guy.
Thank you, Anna. That's and great to be here. Thank you, everybody, for inviting me. So I'm glad actually to do this online. I do say this very rarely nowadays. Everything is online, but this is actually GFP is actually a structure I like online. 4 weeks. This is the last one. Very good. So I try to speed it up a little so we have more time for general discussion, and then the speaker after me can also have time for his talk. So bear with me when I try to share my screen. I hope everybody can see the presentation as well as hear me and see me.
It's perfect, Guy. Thank you.
Okay, thank you. Thank you, Albert. Again, thank Anna for introducing me so nicely. That's great. Thank you. So I'm here. This is the first time actually I do this, and I don't feel right to do so because I'm just, advising the WFP. So on some days a week on a lot of disasters. So here I actually try to present a project that they have initiated with the National Disaster Management Agency in Mozambique. And I've been part of it just a little bit doing, helping out with the modeling, etc. So I don't feel at ease to do it. I do my best, but hopefully if there are questions, you can also get your questions to Michael Manalili or myself actually would try to answer. So I'll talk to you today about some very big, I think personally, innovation project that uses drones for bespoke local flood risk assessment in a basin in Mozambique. So let me get started with a little bit of background. So INGC, as I just said, is the National Disaster Management Institute in Mozambique, and I don't dare pronounce it out in Portuguese, but I say Portuguese because later on you see that language can be a barrier, and it's very important for local community work. So they have a partnership with WFP, of course, with the country office of WFP over in Mozambique, Maputo, to look at projects that would help them do disaster response locally and at government level better using newest geospatial technologies, or even like here, unmanned aerial systems or UAVs or drones, as we like to call them. So how do you actually get this done? You need high performance computers, you need a drone fleet, you need personnel that's trained. You get the big data. Everybody talks about big data, but how do you then analyze, extract useful information that could be used to respond to flood disasters at the very local level, at town level or village level? So again, some background here. So Michael, who I work with a lot, at Michael Manalili at WFP in Rome, had actually a 3 weeks field support to the Maputo country office of WFP. There, the idea was to work on a drone project and to look at a past flood event to see how we could respond to that using newest drone acquisitions to build digital elevation models, have photos available for more asset recognitions and exposure mapping. And this was all funded by the European Civil Protection and Humanitarian Operations called ECHO. And of course, in partnership with the Mozambican government and INGC. So the purpose was actually very easy. It was to see if, how would you increase preparedness with the data analysis collected from a drone? They were very interested, the government was very interested in using drones to see what else they can do at local level. Of course, Mozambique is a huge country, and every basin is very much prone to flooding, to a lot of flooding, and a lot of flooding regularly. So it's not something you can easily do. This is just an example of one basin in blue. The outline is in blue. And hopefully you see all the little airplanes that actually tell you where their drone were flying. And some numbers here for anybody that has done some drone flights. One flight on a drone takes 20 minutes max because of battery lifetime or duration, let's say. So 20 minutes max, one flight, and you can maybe do half a kilometer squared if you're lucky. So look at these numbers. They did 235 drone flight missions, 58 hours of flight time, and almost 160 square kilometers of area covered. Now, if you put that in context to my country where I currently sit in Luxembourg, that is a big area for us. But if you look at the map of Mozambique, of just one, the Lincunco River Basin is a very small area they managed to get. If you look at all the rivers there, if you can see them. So that's over 0.5 terabyte of data. How do you get this to the people actually needing to process the data? So all of these are big challenges. Almost 300,000 aerial photos and 12 people with 4 teams doing the drone. I don't think that's a lot of people, by the way, but given the flight missions. So they did a great job. And very often when you have these drone flights, you would have ground control points and with very good GPS measurements. Here, that wasn't really possible for most of the time. So again, another challenge. So here's just a photo to show to you that it's real. These are the people that got trained by WFP and a drone service provider to tell them how to do mission planning. So all were very happy, took it very seriously, and ended up with actually some very nice data, I think. So first of all, with all these photos and photogrammetry of processing, we could actually do a digital elevation model. So that's what they did for us. But then the big question they had was, what can we all do with this data? and actually to respond to disasters locally? It's a very good question. So if you then take the example of what we have currently available in Mozambique or in any other country, you could go for global flood model. As we know, a lot of providers have access to them now. JRC have the European Joint Research Center in Italy have a global hazard model. Typically, they all have more or less the same processes. They represent more or less the same processes. They lack some quality data like the DEM in some places. They lack flood defenses maybe. They lack dams. They may, but they are very good for certain things. They're very good to give you regional awareness, regional hazard assessment, regional risk assessment. If you have high quality data, like in the US, for instance, they may be able to provide you with very high, even detailed local assessments. But here in Mozambique, where there's typically not a regional digital elevation model available that of high quality, there's not easily accessible high quality discharge or rainfall available. So there you have a global model that is not really doing great at local level. So just to show you the area where we actually worked with the drone and had a local town completely flooded in 2015, that global model here doesn't pick up much other than the big river running through it. So this is the thing. And actually we then thought, well, was the 2015 event so big? And actually you see the relief web report with the photo there, it was actually massive. It ripped away most of the houses. It's a small town, but I would say pretty much in the wrong location for natural flood processes. It's right on the edge of a big river, low-lying floodplain, the typical scenario, and then fishing town. So you can imagine what happens during a big flood event. Here also the GFDR report. A lot of people got killed in that basin, and it actually cost Mozambique a lot of money. So here we are with our drone-based DEM for this particular town called Mokuba. So the spacing of the pixel is absolutely marvelous. If you think that the only DEM so far available was probably SRTM, 90-meter resolution, few meter in the vertical accuracy. Here, you then go from that DEM to a 40 centimeter per pixel and half a meter in the vertical accuracy. So you completely change the game in that sense. But luckily, working with national government and local communities, they actually tell you that there's a gauge that measures the discharge in a river that most people doing global flood modeling wouldn't even have heard about. So that enabled us to build a fairly standard, I would say, 2D flood inundation model. You have discharge, you have a downstream controlling boundary. You set it up over this very small domain size, but very high resolution, and you see what you can do in the flood model. So the great thing is, because it's observed discharge and a relatively good DEM, the model actually doesn't do too badly. So that's what you can do with the DEM and looking at flood modeling. So here's something else you can do. If you get all these photos that generate the DEM, you can also use these photos to look at asset exposure. So basically map buildings, map roads, and you can share that then to let's say to other platforms, or open aerial map, for instance, is something like OpenStreetMap for for aerial mapping essentially. So you can also start validating the famous Facebook high resolution data for Africa in that location, because you get something higher resolution now that the satellite data that Facebook used. So you can do all this, but then some people may wonder, I myself wonder, why don't you use OpenStreetMap to look at these things? Well, let me skip this slide, I'll come back to it later. So here, for instance, great example, 2014, before the big flood event in 2015, OpenStreetMap, no data. No data on where a building was, no data on where roads are, nothing. So that means after the 2015 event that the humanitarian community started mapping from commercial satellite images to put it into OpenStreetMap. So now if you go to OpenStreetMap, you actually find the buildings and other assets in that database. And that's very, very common in many countries around the world, where we all believe that Google or OpenStreetMap project have mapped everything. They have mapped really just a little percentage of what's out there. So humanitarian communities very often, like also Doctors Without Borders and WFP, they start these projects where they map assets on commercial satellite images from Maxa, for instance, and feed it then to OSM. So great. So now we have this data available from OSM, but is it really any good? So we compared it to our drone image. We see that some is missing, but in general, it's really good. So that's also one thing to use the drone for. You can actually check whether the data you have in these freely available sources is actually true, or whether you have more buildings that were added more recently, etc. So you can augment your, let's say, your exposure data. So if we overlay that then with the drone-based DEM and our model, we can start seeing why this is useful. For instance, in this flooded situation, at some time step in the 2015 event, you can see that some buildings already start to be covered by water. And this is not even looking at the peak. So going back now, so if you see, okay, let's take the maximum flood extent of the 2015 event based on the modeling and use that exposure data, you can really do some nice numbers here. And you can very quickly see how disastrous that event is. And bear in mind, if on the global model, you would probably see just a few pixels within the river channel, nothing else, no flooding happening there. But as these global models also improve, you may see more similar pattern to the drone here, to the drone-based model we use here. And you may also have noticed that in the drone DM, that bridge is totally gone. And that is because in the 2015 event, that was totally gone. So another way to do it would be first to reconstruct that bridge, then to see if the model also goes around that bridge, or what happens to the flooding. But here we didn't have that. So we just assumed, okay, let's run the model anyway, see how well it does. And the thing is, with these statistical analysis, like counting the buildings that are flooded, you don't really know how well you're doing. But you can, of course, put it on online platforms to look at, like basically risk. So color it with a risk-based index where you say, okay, this is, what is the number of structures? How are they exposed, given the different time steps of flooding you see in the model? So the WFP shared that on different databases within the humanitarian community. So then there was the big question more from my side is how do we even know this model is doing anything correctly, right? We're assuming it's a good DM. We're assuming it's a good discharge data that we feed in the model, but how do we know it's good? We can use, here, Digital Global, I should apologize, this should say Maxa for now. So high resolution reference image, we used it, luckily a bit cloud free. You see the same pattern of the river channel that you saw in the model. And we put a few pins there just to see, okay, do we actually flood these areas as well in the model? And luckily enough, we did. But as I said, it's a large event. So it's very easy to say, well, yeah, that's natural. It floods easily in the model. Then you can do something that is typically also done in most models that are developed in countries like where the quality is high, of data is high, and you can get some event pictures, let's call them, either from local community or government officials that were there, took a picture, and you can see, okay, in the picture it's difficult to recognize where it was, but that was definitely the bridge that's now gone. So, I mean, not too bad that there's a lot of water there. That's all you can say, essentially, that there's a lot of water also on the floodplain. You can see some buildings are destroyed. So the model is probably inundating correctly. One other thing you can do, and actually I think this is the greatest thing I have ever seen in any flood modeling exercise, is that we decided why not do a small survey, easy survey, 5 questions in Portuguese to the community that got flooded, and spread that around as much as possible to get a lot of responses from the local people. So individuals whose houses they actually were that got flooded or destroyed. First question, And you can see it's in Portuguese. I try to translate as best as I can. So first of all, number of residents in that building, how deep was the inundation? So this is a very tricky question because obviously we don't want locals to come back to us and guess at centimeter level how high the water was standing. It's very difficult to do even for an expert to say, okay, this is like 80 centimeters or maybe it's 90, I don't know. So we just went with the human body and categorized it. So we asked the people, was it above your head as an adult? Was it at your chest height? Was it at your waist height? Or was it at your knee height or ankle height? Or, also was it above an average height kid or, a toddler? These kind of questions, very easy to answer. So this person, for example, here, where you see the cyan square around the house, said that his house he was flooded above the head. It means in Portuguese, I hope so. So we were thinking, well, this may be 2 meters or not. Are we sure this is right or not? We cannot be very sure, but hey, they uploaded photos as well. So yes, we can be sure because as you see on the photo, his house is totally gone. So it must have been at least what he was saying, or at least let's put it this way, it's not unimaginable that what he did say is correct. The house is gone. So we have about a couple of hundreds of these points in different locations, as you see here. And again, we see our model does not too bad, but actually having these number of spatially distributed data points and from individuals reporting numbers or text, but it's more or less convertible to numbers with an uncertainty, let's say, of more or less 10 centimeters, you can see that actually the model has also in some places a hard time to match this. And this is very typical. It's not that we expect models to do great with great data if you start having this kind of spatial distributed data. But remember, this is a town that's very often completely omitted from global flood models, also from relief services, because it's not showing up on a satellite image either. It's very cloudy. It's in the middle of complex terrain. The river is relatively small to be captured well by a 30-meter Sentinel satellite image, for instance. So, but here you have a community that is in serious trouble, and they tell you that actually, we give you data if you want data, but then we have trouble matching it with the model in some places. Here's another example of what we've done. So here's the person that worked with us from INGC. He gave us real-time readings from the gauge, and we ran the model, and we could actually start validating it real-time to see if his water level readings that he has actually make sense or are in line with what the model shows. So this is via WhatsApp, of course. By the way, WhatsApp, I think, is one of the more widely used, if you like, mobile device apps in these parts of the world, because mobile phones do actually work in contrary to Wi-Fi networks, for example, which very often don't work. So mobile networks is not too bad at all. And that's what we did. So going back and asking ourselves, so what else can we do? I mean, malaria is a problem in these regions. So could we do something like with this DM and the model to look at mosquito breeding regions? And fair enough, yes, we can, because if you are left with areas that are not drained perfectly in the model due to rainfall, you can assume that that would be an ideal breeding ground for mosquitoes. So that's something we could do, more of an innovative use, I would say. And so this is how we did it, a simple GIS exercise, essentially looking at what water is left in the low-lying areas and doesn't drain back to the channel. It basically is a desired spot by mosquitoes for breeding. So something else we did with the, I think it's the WFP team for artificial intelligence. They start using these imagery from the drone for counting humans, essentially, seeing humans in images, recognizing them and seeing if they are in need of rescue. So that's something else you can do with, combining the drone data with artificial intelligence. So there's a lot of innovation possible if you start having these drone data at very local areas. And we presented, of course, the results, or the results were presented, let's say, at national level. with senior people, also representative from Brussels, WFP Rome, and INGC, ACO representatives, so all the guys supporting this project, and also the local community. And there was even a poster conference as we know it, showing what's possible. And so essentially, I think that's more or less my talk. And I just want to say a few things at the end, that because they now see the value of this, they of course are very eager and over-ambitious. They now want to do it for the whole of the province, if possible, all of Mozambique. But of course, with a drone, that's a bit of an over-ambitious project, to say the least. So we need to see how we can scale what we've shown here to make it possible for other regions in the country. And there's a lot of work going on also with the Red Cross in this respect. And even ESA is very interested in running an InCure program to look at the drone data that was used there to see how can we use it for better flood mapping in Sentinel-2 images. So yeah, that's it for me. I mean, if there are any questions, please feel free to put them in the chat. I haven't had a look yet, but I will, and try to respond to them as best as I can. If not, get back to me by email and I try to answer. And if I can't, I will forward them on to WFP or INGC. Thank you.
Thank you very much, Guy. That was very interesting. I innovate a way I love the explanation of how you collected the water height data. That's very interesting and innovative, and of course, taking advantage of the mobile networks. So there are a couple of questions. I think we could take a couple now. One from Samuel Rufat. No, actually, no, I'm sorry. That was for... Okay, we have one. How did you get the building mask in the OSM images, the OpenStreetMap? I actually had the same question, right? You had a mask. Did you do them yourself, those classifications?
Yeah, so in the OpenStreetMap database, essentially that's how it works. So essentially there's it's all based on volunteering mapping. I don't know how many of you actually know how OpenStreetMap works. It's very volunteering based. So essentially, I hope I'm not saying anything wrong here, but essentially I think Maxa, used to be Digital Globe, provide the most recent high resolution satellite image in a given location in the world for free, just as a visualization. So you cannot access the imagery or download it, just visualize. And then you essentially log into OSM and you start mapping, vectorizing the area around the building or around the asset you want to map. And then you save it, and that's how it gets saved in the OSM database. So it's all very much a volunteering effort. There's not 100% sure that what is mapped is actually real. That's why I think, but it's validated in a way, but that's why I think having like local area acquisitions like from the drone may be a good way to also validate OSM data. But unfortunately, because it's a volunteering effort, OSM is not advancing as quickly as it should be. So many areas are still not mapped. I mean, really badly, for example, is Nigeria, or Niger, where there's also a lot of drought and flooding and disasters. There's hardly any road or any building mapped yet. So, but there are a lot of villages and towns and cities. So it's a very unfortunate situation.
Okay. We have a couple more, but I think we're going to go to our last speaker. And okay. we have them here. We'll pull them later. Okay, so
thank you.
Yeah, thank you very much. So our next speaker is Jurgen Wegmaker. I apologize for the potentially incorrect pronunciation of your name. So Jurgen is with FloodText. He's going to talk about ground observations from the media for real-time and historical flood assessment. He has 20 years experience with underground water management, has a master's degree in civil engineering from Delft University of Technology, and worked on water and development projects in 15 countries in Africa, Asia, and the Americas. He has field experience and has been very much focused on what is happening underground and at the local level, inspired by the large volume of data shared by people during floods via the social media. And in 2014, he founded the company Flood Tags, which is what he's going to talk to us about today. Welcome.
Okay. Can you see my screen?
Yes.
Okay. Okay, thank you for the introduction, Anna, and pleasure to be here, being invited by the Global Flood Partnership. Today, I'd like to show some examples of how you can use media data for real-time and historical flood risk flood assessment. First, for those who don't know us at all yet, our starting point is actually that there's millions of online posts on floods throughout the world. Peaks of up to 100,000 tweets, for instance, when it floods. Here on screen right now on the left, you see some content of ETA, which already a little bit longer ago. In the middle, some content of Italy, where it was flooded a couple of days ago, and the three on the right are actually floods of today. On the left, there's Malaysia. In the middle, there's Chennai, where there's a flood right now, and on the right, there's a flash flood in New Zealand. We saw this happening and had the idea to start collecting all that data and analyzing that data. So this is what we do. We collect the data from different sources, from Twitter, from blogs, from forums, from a lot of news sites, and then we analyze it. We do that with our partners. It involves event detection, information extraction, and then we distribute the content via an API and the dashboard. So what does that look like in real life? This is the emergency operation room at the Philippine Red Cross in Manila. They have, of course, Philippines is very much a flood-prone country. There's a lot of floods going on every year, every month. And they had the problem of knowing when it floods at a certain point in the Philippines. What we created for them is a notification on the basis of social media that they take in their own dashboard. On the left, there's the admin dashboard for their own operation center, where they get to see where there's an elevated number of tweets coming in per location. What happens then is they start calling to these different locations to follow up on these individual messages and to get content from the ground. And then they start monitoring the situation via our dashboard. Here you see a visualization of the dashboard, where we have per tweet or per social media content, you can exactly see where it is located, what it's about, and so that they can have a real-time follow-up of anything that's going on. Another example of what we do also with the Red Cross, but then in Tanzania, and they were kind of interested in this system, but they didn't have a lot of Twitter, of course, or of course there's not a lot of Twitter in Tanzania, but they were using WhatsApp a great deal of sharing information. But the downside of WhatsApp is that they couldn't have any automated, structured intake of that content. And so what we did is create a bot in Telegram, where they have now 125 members, volunteers, disaster managers, that are reporting about floods. And we insert them in a platform, Community Water Watch, that we developed together with Deltares and Tamo, which is a very local forecast and monitoring service. So here you see monitoring of water levels coming together with forecasts, coming together with observations on the ground. And that's then being used by the Red Cross to monitor the situation, and also by the authorities to monitor the situation as it unfolds. Another example is model validation. This is not only in real time, but moreover looking at past events. This is for a use case of index insurance, where there was hydrometeorological model was developed which had falses. And we were asked if we could find false negatives and false positives of their model. So we started looking at newspapers of the past 10, 15 years. And what we do is a process of natural language processing to detect events, and then create a table of these events that have dates, that have location, that have affected people, that have overall damage. That was done. And with this, this serves as an input to validate their and improve their model. And after that, right now we have a real-time monitor using all the news sites and local news in Myanmar, and we can create event notifications, and they can see whenever it's flooding somewhere in Myanmar, and then they can start to investigate further. And that can be acquisition of further remote sensing data, or and to even the presentation that he gave, follow up with drones or any other type of follow-up that you can think of. Now, going a little bit deeper into Myanmar, we had the request was a highly automated system, and so we started to we wanted to have quite a high precision. So we took to develop and train the text classifiers in 3 local languages, also in Laos and Cambodia. And that's an entire process of annotation and development. And we did that for text, and we also did that for images, together with partners, Radboud University and Vision Impulse, where you can see persons and also water levels. When there's persons or cars in the water, we can detect what kind of water level is in the pictures, and so we can create kind of a high precision on events. And conclusively, we have a process of corrections and continued training via a human in the loop. So via human in the loop, you can go to the articles and just adjust and override the system with your new information. It goes for text as well as for images. So that latter process is the process of all the annotation and classification is kind of time intensive. So what we needed to do is find more ways that we can do this natural language processing and information extraction. So actually we split it in 2. One, we have rule-based systems that have AI support for a quick understanding of what's going on with reasonable precision. And on the other hand, we have in-house developed AI to really reach that high precision. And there's just more work. What comes out of it is real-time flood-related articles, and in both cases with a time and a location. But if you dig deeper, you can also get a further assessment of damage figures, number of evacuees, casualties, etc., etc. And then comes the detection. For a standard level, we can use Twitter. Twitter is quite well for the monitoring of large floods, and you would get many of the smaller floods as well. If you want to get all the floods, you need to go to a broader base of media data. And then you can actually get a very good event detection in any country that you want on the basis of online media, of news media, blogs, forums, all these sources. And they're translating the coverage. It's quite, easy is not the word, but you can do the left method quite well. So right now what we have is we've covered 10 languages and we have this running in over 50 countries. And the other one is at request. We've got it covering now for three languages and expanding. So it's more work, but you can do a lot more with it. Back to some examples. This is an image that I received from John Galantovich. on Hurricane Eta. It's based on SAR images, flood depths, and what I always like to do is see what happens if you look at the same window with flood observations. And here we have it a little bit mixed, and you see that there's a lot of overlap, and there's also some mismatches or differences between the two maps. There's parts where you do have tweets and content where it doesn't seem to be flooding, and there's definitely also places where it seems to be flooding, but there's no content. The exact reasons behind it, I'll leave it for another discussion. But the take-home message is that by combining different sources, it's definitely wise, and you can get a better understanding of a situation, a better validated flood maps by combining these sources and adding the ground truth data. Thanks, John, for sharing this. Another example is we've been working with ICI. ICI is a satellite imagery provider. They provide for different sectors, maritime, also disaster management, and they provide real-time flood maps as well. You should check them out sometime. And what they wanted to do is to improve, as one of the inputs to improve their maps, is look at the content that we could provide as flood tags. And we looked at Tochigi. Tochigi is a city in Japan, was severely hit. And the question was, what is exactly happening in this densely urban populated area? And so we started looking, and this is not real time. This is when we have a couple of hours to spare, then we can find these kinds of pictures in the web, or from the media. This is a location very near to the station. Actually, ICI asked for a number of very good water depth observations. So that's what we started looking for. Here you see, of course, a very good one. You can fairly estimate water depth over here. We also looked at other places. This is the main street in front of the city hall. We looked it up on Google Street View. It wasn't difficult to find. And here you can see a very pinpointed, good, pinpointed location where you can have a water depth. We did the same thing for the Doroyaki shop, where there was a report of flood. We found this image on the web, and we found it also on Google Street View. So what we actually provide, what we can do, is when there's an actual flood happening, or when you really want to know where a flood has been happening, you can look at the media and get good pinpointed data on water depth and other impact factors. Back to the content. There's not only flood observations there. What we did to see what kind of content is there, or what we did to illustrate that, is in a random period of 1.5 hours, we just collected a high number of tweets, and of the remaining 2,500 that are relevant in 1.5 hour, we started annotating all the different contents. And here I just picked out logistics. 8% of tweets are about logistics, which is quite relevant. We see that accessibility of flooded areas is asked to us a great deal of times, and we have quite a lot of content about that. From authorities, but definitely also from people who just say that there's roads that they cannot pass, and perhaps they wish they would have gone by bicycle. Is what this one is saying. So there's a lot of different information in these in the tweets. Just for this set, we saw that 13% was about ongoing flood extent. 50% had impact data. 1% had like a real information on the causes of floods. You have to think about these kinds of tweets. Retaining wall next to collapsed following heavy rains. 1% of content is about that. There's flood forecasts from citizens, like expectation and worries, and of course from authorities. 8% of logistics, and 17% of flood policy that are more discussions on reasons of flooding, like encroachment, like trash, like embankments that are not well designed, etc. So a question that we get a great deal of times, and I wanted to address that, is what do you do in countries where there's no media data? And actually, we haven't had that experience yet, because there's no countries where people are just silent when floods. So there's always countries, there's always content in all different countries for all different use cases. And what we do actually is always start with a quick inventory of data for the different use cases, possibly including an event report, and then you can start either real-time monitoring or a more elaborate risk and trend analysis. Another question that we get a lot is, can we get the data for research purpose? And yeah, obviously, there's a lot of topics that are very interesting to start exploring, like improving the flood maps and flood forecasting by using media data as a supplement. My last sheet is what we can concretely deliver to you. The GFP is about getting science to the end user. We've had a lot of science done until in the past 5 years. Now we are really at the end point of delivering this to end users with success. What we do is a real-time delivery of media data, as you've seen, on a global level and country per country level. This is accessible, this is operational. We provide event summary. If you say, well, I really want to know everything about the Chennai floods that have been happening today, we can deliver that. And of course, we can also support further two-way communication in Telegram, but also in WhatsApp or in Facebook Messenger to add more content via crowdsourcing. This is my presentation. Thank you very much for your attention and for giving me the floor here. Thank you.
Thank you very much. Let's see, I'm seeing if there are any questions in the chat. And Mark, feel free to step in if you see if I missed any.
I've got one for Jürgen.
Yep.
So it strikes me there's quite a lot of the data you're utilizing is quite messy. Is there a lot of manual input in the process, or have you managed to streamline most of that?
Messy in the sense that, of course, there's a lot of different content. That's correct. In the real-time feed, we have we're doing a lot of filtering, obviously, and so there's no content, or the content that's unrelated is quite little. But to separate forecast from damage, from affected people, from that's a little bit more complicated. So we don't do that in real time, or actually we filter it out in real time, but it's still messy. We can't really create on-the-fly tables of how many people are affected, if that's what you mean. So in real time, we just provide the data as is for responders, and responders are actually having, this is sufficient information for the responders to act on. And then for past events, we can list all this information and process it.
Thank you. Yeah, that was a great answer.
All right. Albert, you want to go ahead?
Yeah, sure. So, and I just pasted it in the chat as well, Jürgen. Thank you for your talk. That was great. I'm wondering, so it looks like you mostly look at on an event base, right? Either an event that's just occurring, or a past event or something. But have you looked at trying to build flood risk maps from decades of old media data that you can gather, and then have an idea of, okay, these are really the flood-prone areas in a country or in a city.
Yeah, definitely. No, we've done that several times. One was for Myanmar, of course, where we have a longer history, and if you put all these events on top of each other, you get like a heat map of high flood risk. We did that for Tanzania as well. We did that for Uganda as well, as input for forecast-based financing, where it's important to see what are the locations where it frequently floods, really on the basis of how people experience it on the ground. So yeah, we've done that, and I think that's a great way to use the media data. Yeah,
that's awesome, because something similar is tried with remote sensing, right? Where we got now decades of satellite information. So it would be nice actually to overlay those different products and see if there are gaps or not, and why that would be if there are gaps from the different data sources. So that's awesome.
Yeah, totally. And from the media data, you can also get small floods, right? So if you would need to do all the remote sense data of 20 past years, perhaps that's a lot of work. But if the nice thing about this data is it's more easily accessible, and you can get like a heat map of something happened here in 2016. Let's acquire some remote sensing data and start analyzing.
Yeah, cool. True. Yeah, thank you.
Okay. Thank you. I see a couple of questions that came in earlier for Colin. One of them is, how do you link the 44 resilience sources with the 29 flood outcomes? Is there a way to validate? Is this a way to validate the framework? How often did you get a chance to do a follow-up of the 44 sources after a flood, and what can be learned?
Okay, thank you. It's a good question. I did actually type a quick answer in the text, but I'm happy to share more. I mean, the 44 sources for the more comprehensive study, they are trying to get that snapshot of resilience over time. The 29 outcomes of how things are performed are very much focused on, did those things operate? So, for example, with the 44 sources, there are probably questions about physical infrastructure, providing the community access to markets, access to school, access to hospitals. Now, when we get to the post-flood, rather than going through all of those, we tend to ask the question, do you get access? We ask them two questions. One, did you get access from your house to a safe shelter? So we're asking them about lifelines. And then the second question is an access question. Do you have access to all the services you need? We don't then ask them, do you have access to the market? Do you have access to because what we're doing in the post-flood environment is just really saying, how has that community performed? So we don't want it to be as long an engagement as the more thorough baseline and periodic assessments. We want it to be quick. So we're asking the community literally, do you have access to refuge? Do you have access? And not going into the details, school, markets, local transport services, et cetera, which we have in the 44 sources. So I hope that answers that question. And can I just comment on the last discussion? One of the things that we are particularly interested in is going back to provincial newspapers in local language and tracking up the stories about flooding, because one of the things is floods over a certain threshold tend to get reported on, and they tend to get picked up in media, because there is an obligation for district disaster officials to report on them. But it's those more recurrent floods that happen frequently, but to smaller members of the communities, that can have a really erosive effect on people's livelihoods and escaping poverty. And what we're interested in trying to unpack is, what is that threshold and what's happening below there? Because those floods that potentially could be really the negative drivers of why are certain members of that community really struggling to escape poverty? Because they don't seem to be in the flood data. Well, it might be because they're getting those recurrent hits all the time, and it's just having a negative impact. So using provincial newspapers, and the other great thing about provincial newspapers, when you then ask communities about, oh, by the way, in 2018, there was reports of flood in this area, were you affected? It triggers memory. And then you can get that collective memory, not just the individual memory. So using media to trigger collective memories or test collective memories. Thank you.
Yeah, totally agree on that, Colin. And I think the beauty of the newspapers is that we don't only focus on these real big floods that everybody knows about, but what's really happening on the ground in these, what's the real hurt, what are people really experiencing on the ground with all these small floods that are really pounding them constantly and just don't reach the mainstream news anymore.
If nobody has another question, I have one for Guy. So let's see, Guy. I found it really intriguing to use drones or OpenStreetMaps, for that matter, to map houses and to have to get a better understanding of where are settlements, where are properties compared to the floodplain and areas that are more flood prone. And I'm actually wondering if that could not be, there must be machine learning algorithms that are used by Digital Globe or that are used to the data of Digital Globe or Maxar to detect that automatically, right? And if you have those high resolution imagery from Digital Globe / Maxar, then you can basically automate that and only for the areas that are like in Bangladesh, but Bayes showed there's so much flooding there, so you can have an annual update of your settlements and how those are evolving over time, and therefore are larger communities at risk or not. Is the World Food Programme thinking of that kind of data to implement that?
So actually what you're saying is very true, and it does exist. As you probably know, what is called the Facebook high resolution data set of settlements. That's exactly what they've done. They've used Maxar, Digital Globe, imagery and machine learning. So I think Facebook provided most of that machine learning technology, and then the image is very high resolution, I think 30 to 50 centimeters. So of course, absolutely, they did that. And if I'm not mistaken, that project is updated as well, or should be updated on the biannual or something basis. But as far as I know, not everything has been mapped around the world. Also because, if you think about and Maxar data is not available everywhere. As far as I know, it's not the reason these satellites were built, and it's not the purpose. They were built for tasking, and as most of you know, for very particular agencies to task. So they're not available for the civil applications to say, okay, let's get images everywhere. Very soon, though, with more private sector satellites of that same capability, we may have something that could really look into what you mentioned. And coming back to the humanitarian WFP, yes, they do have, as I mentioned, an artificial intelligence team. They have developed something called DEEP, on deep learning. And it's exactly meant to do that. But at the moment, they focus on drone data to extract building footprints. But I would say if more satellite images become available at the very high resolution for every location, that would definitely be much better way to do it. Yes, because drone images is too high resolution for the task at hand, and it's very often very small areas that can be covered only. So the high resolution satellite definitely the way to go. And machine learning, yes, absolutely.
Yeah, thank you. Great. I otherwise have one other question if nobody else.
Oh, sorry, I was on mute. Go ahead, Albert. I was on mute. I was talking on mute, but you go ahead.
I have.
I'm paying for my right. Go ahead.
A very short, well, I'm not sure if it's short one. For Base, I'm just wondering, Base, the presentation you give is so, you give so clear the devastation, what's happening in Bangladesh, and that the amount of people that are affected by flooding every year is increasing so significantly. And I'm wondering, you know, is this just a problem of Bangladesh itself, with so many people in a flood, living in a flood-prone area? You can only do so much, right? If funding is no limitation there, what would be the first things to tackle to make life better for people living there? That's my main question. Is it, and you mentioned already with you know, the levy banks can maybe, you know, build better to protect communities, but would that be the only reasonable measure to make people more resilient for flooding?
Yes, thank you for the question. I mean, over the past 50 years, we have tried many things. I mentioned more cyclone shelters that has reduced the number of deaths, and also the embankments, protecting like the minor or medium level of coastal flooding or cyclones. But when it is super cyclone like Amphan, you can, I mean, no embankment will work. You know, whatever you build, like the Japanese are building to tackle tsunamis, probably that's not possible because our coast is different. It's, I mean, earth and, you know, soil eroded from river erosion, and highly eroding almost every day. Okay. And also we have trained, it's been, I remember, extensive training program for the communities are there, funded by donors and United Nations and different organizations. Probably all NGOs and organizations are working in the coast. I mean, people are quite knowledgeable, like you have to leave your house if there is warning, take shelter. They're also trained because I showed you before, and back in 2016, they know different sources of income, diversity. Everything is there in place, but I think nothing else could be done. I mean, they have to leave and take it for granted. This is their life. I mean, there will be massive flooding after every 3-4 years. Every year they face it, but massive meaning destroying the entire community, and they build it again and live in that situation. Frankly speaking, that's based on my up until now, my knowledge from the coastal Bangladesh. Nothing to do. They should, yeah, adapt with the situation. Thank you.
Thanks, Liz. And to follow up on that, I thought I understood that you said that 6 months after, I think, I don't remember which flood you were, but they were still flooding in some areas 6 months afterwards.
Yes, since July, still in many communities, the flood water is there. I mean, normally they goes back to the river after a few weeks or a few months, but this year this is exceptional. Flood water is still there.
Yeah, so I can see where, I mean, if there's another event, right, then you have the compounding, you know, effects of more than one event at one time. Anyway, it's, so I mean, I guess.
Can I jump in, Anna?
Yeah, go ahead.
I mean, I think the interesting thing, our program in Bangladesh experienced the cyclone Amphan unrolling at the same time as COVID. And I think what was really interesting, I mean, the thing that Bays highlighted is, yeah, Bangladesh, if the rain falls in Bhutan, or if the rain falls in Western Nepal, that water is going to end up in Bangladesh. That Ganges Delta and that Brahmaputra Delta, those rivers are massive. And virtually any rain that falls in the monsoon on the Himalayas ends up in Bangladesh. And I think what happened this year was Cyclone Ampan hit very early on in the monsoon season, deposited a huge amount of water in Bangladesh, and then rolled into the Himalayas and deposited even more water in the Himalayas, which then compounded the problems that Bangladesh was facing from the deluge that Ampan brought. So their monsoon season started super early with a massive amount of water. And then for the whole of the monsoon season, they just got more and more water, compounding the problem. And I think it was great in Bay's presentation that he highlighted, you know, the underlying signal of climate change on that situation in Bangladesh. But I mean, as a minor reflection, I was at COP25 in Madrid, and there was a discussion in the loss and damage, the Water International Mechanism on loss and damage. And a US person was talking about, you know, hurricanes hitting the southern coast of the United States and causing loss and damage. And Salim ul-Huq, who is a notable climate scientist from Bangladesh, he stood up and he said, yes, but he said Bangladesh is hit by exactly the same levels of cyclones and, you know, extreme weather events, but fatalities are virtually zero because we understand how to respond, we have the systems in place, but we don't have the capacity to reduce the vulnerability and exposure of those poor people. In the United States, you do. You have those systems in place. We don't, but we manage to minimize fatalities. And I think, you know, it's a case of priorities. And I think that's a really interesting story, that when a Category 4 hurricane hits the US, we get this level of impact. The same level of cyclone hits Bangladesh. They're different, but their ability to withstand is much less. So thank you.
Yes, Colin, thank you for your support and adding on to it. I really agree with you. And that's why I mentioned clearly the event can be flooding, but the context should be locally analyzed. The impact in the USA or other in Europe and in Bangladesh is entirely different. Some people really do not agree these disasters are displacing people, because maybe it is not, we have flooding in England, but it's not displacing anyone, literally, or within 6 months they are back to normal. But you cannot really conclude in Bangladesh there is no displacement. Displacement is real, the impact is real, and you should not compare the Bangladesh context with other developed countries. Rightly said by Colin. Thank you.
You're on mute, Anna.
We're just about out of time. I think there was one last question. We'll do those. One last question for Jurgen. Do you analyze the videos to assess hazard in terms of water velocity?
No, I already answered that. Actually, we don't, but now he's responding again. Okay. Okay, no, we don't do that. I'd be interested.
Yeah. Okay. So for Guy, there was another question from Maxim Gusiev. Oh no, I think we already answered this one.
Yeah, I think I answered that. It was about, yeah, I did answer that. I am very sorry, I should have said this. I feel bad, but it was the list flood FP model from University of Bristol. So yeah, I did answer that question.
I've got one question for Bays. You mentioned the disaster displacement, and it's really interesting to see how the nature of the impacts are changing. And I'm just wondering whether that was something that was foreseen before it began to happen, or whether that was a bit of a surprise, and obviously it's a big issue now.
This is very new in Bangladesh. I mean, I would say last 15 years, people being yes, it was previously there, but it was temporary. I mean, seasonal or cyclic. They always used to return back to their communities. But last 15 to 20 years, they are going for more permanent type of migration. That is, the World Bank is calling it climate migration. Like, you forever leave the place or the community because you're tired of coping, every 3 years, destroyed, you build it through donors. you don't know when you will be back to agriculture or other income sources. Young men mostly, I mentioned for several times, they get really frustrated and move to other major cities within Bangladesh. And the recently, last 5 years, you see in that list of illegal migrants in other developed countries, Bangladesh is, I mean, I understand Syria, Afghanistan, Libya. I cannot take it why, I mean, Bangladesh is there. You know, other countries, the climatic disaster hit countries would be added. And the World Bank's report, again mentioning it, they say by 2050, there would be 150 million around climate migrants. I mean, many people really laugh at it and criticize, but I don't know which is true or false, climate change or sea level rise. I cannot see it, but I can see people are really being displaced because of flooding, coastal erosion, river erosion, and drought. And that is, last year IDMC neutrally said 4 million. This year is going to be 7-8 million. That's a lot. And some of them go for permanent migration. And I believe, based on the last few years of statistics, some of them cross borders. And this is a new challenge for us. Apart from community resilience, we need to think more about global cooperation to address this new kind of threat for everyone, even for mostly for developed countries and the developing countries. Thank you.
All right, I think we're about ready to close. You know, if any of the speakers would like to say, you know, any last words before we close our session today? And if
I just want to thank you and from our side, and I hope your network is really very strong, the Global Flood Partnership. And yes, think about all these different new upcoming challenges. Apart from, like, we always stick to flooding. We think flood is localized, but it is now, it has started to impact global migration pattern and global humanitarian crisis. And if we cannot work on it right now, in the next 10-20 years, it's going to be really a major crisis, climate crisis, I would say. So yes, I think GFP can play an important role bringing all together and formulating policies. Thank you.
Thank you, Base. All right, so with that, I'd like to thank all the speakers and also our audience, you know, participants. I think we had up to about close to 100 participants together with the folks that were on YouTube. And thanks for your questions and helping us keep this conversation interesting and relevant. So with that, we will close, and we look forward to getting your feedback on our survey on what you thought about our whole series, GFP series. And Albert or Mark, if you have anything else you want to say.
No, not really, other than awesome. Thank you all for presenting, and thank you, Anna, for convening, and Mark actually for convening this session. This was really great. This was the last of our 4 sessions. We're looking forward to all of you replying to the survey that's going to be sent out in the coming week or something, because it will determine how we're going to have meetings in the future. Like Anna indicated earlier, we had always in-person meetings, but it looks like this is a good setup as well, and we draw more people actually from those online sessions. So we would like to get your input as well on this to see how we can, as a global flood partnership, move forward. So yeah, thank you Anna. Thank you, speakers, and thank you all for joining those sessions. Appreciate it.
Don't forget to join our mailing list if you want to find out what's coming up next. So, yeah.
Thanks, everybody. Bye.
Yeah.
Bye.
Thank you very much.
Bye.
Bye.
See you. Bye. This was great, Anna. Thank you.
Sure.
And we had a good persistent group of, how would you say that, people that stayed throughout the session. So that was good.
Yeah. Yeah, I wasn't sure how long to, but you know, since people seem interested, you know, I was, yeah.
Yeah, it went a little bit over time, but that's totally fine, I think. And you know, people can decide if they stay on or
Right.
if they listen to the recording or if they're just done with it. I'm going to end the session for everybody that's still there, I think.
Okay.
And then the recordings will be made available, I think, within a day or maybe 2 or something. So, yeah.
Okay.
Thank you.
All right. Bye-bye.
Bye.
See you. Bye.
Thanks.
See you, Mark.